Definition 22.1 is going to define several things for us that are going to make it easier for us to be able to work with these things called sequences. Now, the first thing we have here, it says a infinite sequence, and then it says an infinite sequence, an is, so let me circle the word is, and an infinite sequence is two things. Number one that I want you to take away from this definition is that an infinite sequence is a function. Number one. Second thing I want to take away, whose domain is the set of positive integers. That's number two. Now, the set of positive integers is also known as the set of natural numbers. So on example 22.1, I went ahead and put example 22.1 on here again for us to see as a reference. The domain of this function was the natural numbers, which means that this function that we graphed is a sequence. Now, I mentioned that when we first looked at example 22.1, but now we have a definition that backs us up on that. It says that this particular function is in fact a sequence. Now, it also mentions here the an notation. I'll circle that here, this an notation. So what we can do with a sequence definition, because it is a very special type of function, is I no longer have to use this rigorous mapping notation like that. I don't have to use all of that, because the domain is always going to be a set of natural numbers. I can simply do this. an is equal to 3n minus 5. And that would be an appropriate way for me to define this sequence. I still have the equation where I have 3n minus 5 showing, and then the a sub n indicates that we're going to be using a natural number input for the sequence. So it's a much more efficient way of being able to define a sequence without having to go through the rigors of the long function notation that we've seen. So another thing to mention here with this definition, 22.1, it says the function values or terms of the sequence are represented by the a1, a2, a3, a4, and so on. So when it comes to thinking about maybe making a table for something like this, the left column is n still, but the right column I would now say is a sub n. So when I plug in a 1, that means the answer that I'm calculating is the a1 answer, which we know when we calculated it, a1 was -2. And then if I plug in a 2 for n, that means that a2 is going to be equal to +1. And this is plugging directly into the equation an equals 3n minus 5. So that would continue on as long as we have natural numbers to plug in. So it's just a different way of notating it, but it is still going to be recycling a lot of the same concepts that we've had all semester long. Now, sequences don't have to be infinite. They can be finite as well. So it mentions here that sequences whose domain consists only of the first n positive integers are called finite sequences. So if I only wanted 10 points, then that would be a finite sequence where I'm only giving the first 10 points of that particular equations sequence. So that's definitely a possibility as well. In fact, the majority of what we're going to be dealing with in here is going to be finite sequences. It will not be until later on do you start to see things that are infinite.